Throughout SDVoE training, we often reference the typical topology of an SDVoE system, comparing it to that of its matrix switching counterpart. This course will dig a little deeper into this topology and identify each component of an SDVoE system, from control to hardware, and help you understand just how flexible and scalable this technology is. At the heart of a matrix switch system is, well, a matrix switch, and it's this piece of equipment which has long been the driving force behind video distribution. In all fairness, it's done a very good job of it. Not surprising really, because almost every penny of research and development has gone into making this big chunky box deliver perfect image quality from source to display. Unfortunately, R&D is expensive, and as image resolutions get bigger and the demand for perfect latency-free video distribution grows, more and more money needs to be spent making sure the matrix switch can deliver it, and this makes each port more and more expensive to buy. As development costs spiral out of control, fewer and fewer manufacturers are able to keep up. Designers are stuck with only a few choices, and system owners end up locked into a single vendor for their entire system. Functionality also plays a major part in the cost of a project. If features such as video walls or multi-view applications are required, a traditional matrix switch is unable to help. So, extra equipment has to be added, which further adds to the cost. With more equipment comes more control complexity. It takes a lot of programming and testing to ensure the correct output on the matrix switch is selected prior to the multi-view processor selecting the correct sources to be presented within the display, or check the video wall processor is pushing the correct image from the matrix to the correct display. So, how does SDVoE make all of this less complicated? Let's begin by swapping out the matrix switch for an Ethernet switch. Like matrix switches, Ethernet switches also need research and development, but unlike the thousands of matrix switch ports available, there are tens of millions of Ethernet ports available to us, and that makes them an awful lot cheaper to buy. There are also a huge amount of companies developing Ethernet switches, so in Pro AV, we don't need to worry about them too much, allowing us to focus on the sender and receiver units which use SDVoE technology. Now let's turn our attention to the endpoints. In SDVoE, the transmitters, or TX units, are often called encoders because they use codecs to turn audio, video and control signals into data packets. Receivers, or RX units, are often called decoders due to their ability to turn those data packets back into their original AV or control signals. However, unlike a traditional receiver unit which attaches to a matrix switch, an SDVoE receiver or decoder is capable of far more. Whilst they're both able to receive multiple signals from a transmitter, the SDVoE decoder can also become a video wall processor or a multi-view processor, all from a single command sent by SDVoE control, something you would struggle to achieve with the controls on the front of a matrix switch. So where does all this control actually come from? The answer to this is easy. Software. More specifically, an application programming interface. Put simply, this is a set of commands which can be used by any control interface to tell the transmitters and receivers what they need to do or how they should behave. Because we are using Ethernet to transport the data packets, all we need to focus on is talking to the transmitters and receivers in a common language which they all understand. This is the job of the API. There are a number of ways this can work. A popular choice amongst SDVoE manufacturers today is to place this software onto a dedicated small form factor computer, which lives on the same network as the transmitters and receivers. This computer then allows any third-party interface to control the endpoints. You could think of this software as the buttons on the front of a matrix switch, but because it's driven by software, it's far more powerful. Not only that, If you need to add more endpoints, you can. You don't need any more computers, you just need to make sure you have enough ports on your network. So unlike a matrix switch, which can only accept a limited amount of endpoints, an SDVoE system can accept as many as the highly scalable Ethernet network can support. And the Pro AV industry doesn't need to spend millions of pounds finding more bandwidth for the future, because our networking allies are taking care of that for us, meaning we can focus on making SDVoE technology drive the future of video distribution and cement its place in Pro AV as the matrix transformed.